Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love learning new things, you want to skill up, or you just like tech, make sure you subscribe to the channel so you don't miss any of our content. In today's episode, we are going to be looking at generators. Generators are a simple and powerful tool for creating iterators. They are written like regular functions but use the yield statement whenever they want to return data. Each time the next method is called on it, the generator resumes where it left off. It remembers all the data values and which statement was last executed. Let's see an example of a generator quickly. I'll create a new file in my generators directory, example1.py, and in here I'm going to define a reverse function, and in the reverse function I'm going to say for index in range len data minus 1 minus 1 minus 1, then I'm going to yield data index. Now underneath this I will say for char in reverse golf print char. So let me quickly go over what is happening here. So here we're generating a list using the range function. In a previous episode, we saw how we can generate lists using different formats or different techniques. I'll link that episode in the description below. But in this case, we're using a range function. And what we're doing here is we're taking the length of whatever data is passed in here and we're subtracting 1 from it. So it will be 1 less than the length of the data. In this case, it will be 3 because the length of golf is 4. So it will be 3. So we start from 3 and then we stop at minus 1. And the step is minus 1. So what that means is that we're creating a list of numbers starting from 3 and stopping at minus 1. And what that helps us to do is it helps us to go through this data list. So we're going to print the third item or the third index on the data of the data. We're going to print the second index, we're going to print the first and the zeroth, and finally the one in minus 1 index. But minus 1 will not be included because range usually stops 1 short of the endpoint. So we're printing just 3 to 0, which helps us to print the entire list in reverse. So let's run this now. Cd into generators and we'll say python 3 example 1, and that we have it. Anything that can be done with the generators can also be done with class-based iterators, as described in our previous episode. What makes generators so compact is that the underscore iter underscore method and the underscore next underscore method are created automatically. Another key feature is that the local variables and execution state are automatically saved between calls. This made the function easier to write and much more clear than an approach using instance variables like self.index and self.data. In addition to automatic method creation and saving program state, when generators terminate, they automatically raise stop iteration. In combination, these features make it easier to create iterators with no more effort than writing a regular function. Basically, this simplifies the process of creating an iterator by using a generator. Some simple generators can be coded succinctly as expressions using a syntax similar to comprehension list, but with parentheses instead of square brackets. These expressions are designed for situations where the generator is used right away by an closing function. Generator expressions are more compact but less versatile than full generator definitions and tend to be more memory friendly than equivalent list expressions. So let's see an example of these generator expressions. I'll first comment out this, then say sum, or rather print sum of I times I for I in range of 10. Now what we're doing here is we're creating a list compression. We are using the list compression syntax to create a generator expression which we now feed into the sum, which now print or our output. So let's run this and see what we get. So we get 285. Very nice. Let's see another example. We define xvec to be 10, 20, and 30, and yvec to be 7, 5, and 3. Then we will say print the sum of x times y for x comma y in zip of xvec comma yvec, and this gives us the dot product of these two vectors, xvec and yvec. So let's run this and see what we get. We get 260. If you've not gone through the list comparison episode, I'll also link that in the description so you can go over it as well. Let's see another example here for using data is equal to golf. We'll say list. Okay, let's say print list data I for I in range of len data minus 1, minus 1, minus 1. As you can see, this is a simplified version of what we did previously here. So let's proceed and see what we get. And we got literally the same thing. So that's it for generators. If you loved the content, do like and subscribe and share with others. And I'll see you in the next one. Bye.